Hey everyone, got Zach, got Peyton, myself, Dan Scoff. We're about to tell you about severe storm potential. And we got the lights on because we may be doing coverage here pretty soon. We got a very, let's say, ripe environment for severe weather potential for sure.
Yeah, dew points pretty high, mid to upper 60s. Front making its way in. A little bit of clearing ahead of that front.
Yeah, let's get to it and show the radar, not waste any of your time. Newest risk is out, probably a watch going to be developing really quick. I wouldn't quite say Armageddon, but I will say that there's going to be some storms that will definitely, let's just say, oh, hey, all right, Peyton's going to control it remotely. Let's do it. So here's a look at Heil Heating Cooling Mega Doppler, and yeah, so oh yeah, you're using the mouse over there. All right. Hook echo tie might be a stretch just because the ingredients are there for a tornado or two to be possible, but I wouldn't expect super full blown hook echo supercells. Possible, I guess, if they ride the boundary. But here's what's interesting: the graph didn't have any storms developing. So here's a look at the latest mega Doppler. You'll notice not a whole lot of activity, but this is just the start of the cold front that's going to be moving in. It might be nice. Yes, it's definitely nice outside Nikita, but at the same time, it's nice and humid as well. That humidity is going to lead to the chance of some storms. So a lot to go through. We got the newest severe weather risk that came out, and Peyton actually posted that pretty quickly yesterday. Or should early morning. Yeah, 1 a.m. 1 a.m.
11:30.
Yeah, we're going to take a look at some of the cameras here. But first of all, I want to show you the dew points. Golly, upper 60s. That is just very, very humid. There is no doubt about that. If we take a look at what that's doing to temperatures, here's a look at the Harrison WeatherBug Network camera. Boy, a lot of sunshine, a lot of fuel, a lot of time before those storms make it into Boone County. Yeah. So there's definitely a lot of daytime heating. Now, you look at these clouds, they're not very vertically developed, and there's a good reason for that. The lift isn't approaching Boone County yet. Those are fair weather cumulus clouds. Mitchell, no, the Lincoln camera is not down. Now, check this out, Zach. I'll show you something pretty cool. So if we go to main menu, go to here, go to cameras. We can bring up all those cameras.
Oh, nice.
How about that? So Lincoln, there's your Lincoln WeatherBug Network camera. That's showing a little bit of that cell that's off to that's looking south. No, that's looking west now. Yeah, we got to adjust that. I think that's looking south. So we're looking south towards quite a bit of cloud cover, but the sun is coming out from time to time, and so it's kind of trying to squeeze that moisture out.
All the cameras are pointed north or northwest besides
Okay.
And
we don't have the preset set, so you got to spin it around to
what direction?
The right. That's looking south.
Oh.
And that is looking west. Yep. We're going to have to do some presets. Sorry about that. That's a brand new camera, so we just got it up and running.
Yeah.
All right. Let's take a look back at some of the graphics here, and we'll show you. There's the Gaither Mountain WeatherBug Network camera. Look at that. 80 degrees in Harrison, 77 in Fayetteville. It's definitely warm. It's definitely humid. We have a lot of moisture and instability. Now, here's the deal. You look at the high-resolution satellite. These storms are not completely taking off yet. I do suspect that there's going to be a severe thunderstorm watch coming soon. What was the probability of that watch being issued with the mesoscale discussion that just came out? Doesn't say on that?
No.
Oh, that's baloney.
Yeah.
Well, yeah, 60%.
Okay, it doesn't on the outline. So 60% chance. There you go, Josh. Appreciate that. Got an update there. You notice the updrafts that are developing, and there's the line. And so these are the storms that are trying to form. They haven't quite rooted in the boundary layer. They haven't quite developed. Then you've got some sunshine that's off to the west of this big cloud deck. Notice how it is going to start to clear from west to east. And so that's going to really lead to the potential for some storms to develop. Again, that high-resolution satellite showing along the boundary. This is where that front is. You can see it very clearly with the cumulus congestus field right along the front. Some of the storms that develop behind the front won't have the greatest potential. So we're not going to have to worry about those storms, which is why they actually cropped out the latest severe weather risk. So Judy says the sun is out, beautiful day. Well, guess what? When the sun's out and you have a beautiful day with a cold front off to the west and severe weather potential, that can spell problems
Yeah.
with thunderstorms because that fuel for thunderstorms with the sun kind of heating up the atmosphere, heating up with the temperatures, that's kind of like putting your a pot of water on a stove and you crank up the burner. That creates a lot more boiling of the atmosphere, which will eventually lead to more storms. So what's going on? Yeah, it kind of feels weird outside. You know, severe weather days just have that feeling. And if you talk to people that are in storm activity, sometimes, you know, they're just like, wow, the sun was out. And then all of a sudden the storm came out
Right,
of
yeah.
nowhere. That's what you always hear with like storm stories and stuff like that. So that's what we're watching. That's what we're looking at. All right, there's a severe thunderstorm watch that is included for Southwest Missouri. This is Berry and McDonald County. Grove, Oklahoma, currently not in that risk. And just to let you know, Grove is going to be coming through that area pretty quickly. Now, couple updates to the severe weather risk. Number one, the risk has been cropped out on the western edge, and that's because of the front that's dropping through. The level 2 risk, and Zach, we've been all looking at these soundings and stuff like that, and the soundings are fairly impressive.
Yeah, we got a
For
lot of
thunderstorms.
shear along that front, and you got a lot of instability. You saw those dew points, so the ingredients are definitely there for these storms. Still some questions though, with the energy coming in,
Yeah.
and if that front can outrace that energy. So
The question is if storms will even develop because
Yeah.
they're struggling right now, and the models have been kind of indicating that there could be a little bit of an issue in terms of timing. So
Yep.
you're asking about timing, and no doubt that's definitely you can feel it outside. So here's uh, Justiniah is asking what time. So let me go ahead and show you. You'll see it. We have it right here from 3 to 9 o'clock. So the severe storms possible. 3 o'clock, we're obviously already at 3 o'clock. But if you see off to our west on Heil Heat and Cooling Mega Doppler, there are some storms that are popping. That's why we have that window. Now, if we put this into motion, let's take off the mesoscale discussion, by the way. That's just the area that we have the potential for a watch. If we put this into motion, you're clearly going to see these storms making their way eastward, but they're not really exploding, in my opinion. This doesn't look like 3000 K.
kind of weakening a little bit.
They're capped. Yeah. They're still capped. And we talked in detail about what the cap is. It's a layer of warm air aloft that will prevent thunderstorms from developing. Let's go back to now the individual threats. I'm going to take the camera off the screen. Remember last night, if you watched our severe weather update in our live Facebook, you'll see right here 1 to 2 storms possible that could produce tornadoes. That wasn't even included in the day 2 outlook. One of the things we really have to watch is the potential for very large hail. Over 2 inches is not out of the question with the type of environment that we have. Now, you'll notice that does cover almost our entire weather coverage area. But I have to preface this. If you're new to these weather updates that we do, this does not mean everybody is going to see that large hail. It's just the possibility of the potential is there to see that hail if storms develop in that region. So it's like kind of like a potential. It's not this is exactly who's going to see large hail. Because if you're looking at this, oh, Benton County, the entire area sees 2-inch hail. No, that's not right. It's just this is the threat. This is a possibility over that entire region. Damaging winds also will be possible as well. So a lot of people asking about the models. Well, they're kind of trash, and so we'll see what happens here. No rain in Farmington, clearly not, because you can see on the radar there is no rain on the radar. It's all kind of off to the west right now. That's on Heil Heat and Cooling Mega Doppler. So if we go back to the timing of this, and what the models show, they actually have a pretty good handle on this. Let's see what they do. And, maybe there's a chance that we remain capped. It's not out of the realm of possibility. It's actually very surprising. And we would definitely dodge a bullet. But I just don't understand what's going on with these high resolution models. It's unbelievable. Of course, it hasn't happened yet. And maybe they're all right and we're wrong. But this one doesn't even develop anything. Nothing. It's capped. I mean, what do you think, guys?
I think we stay capped.
You
I
do?
don't
Huh?
think there was enough clearing.
What do you think, Zach?
Well, what I do know is that the fact that we are caps,
Yeah.
if the cap breaks, that could be trouble
Yeah.
because all the instability is being trapped underneath that warm layer, and if we do see some clearing, some heating,
So the only way to look at the clearing is we can go to our cameras and we can start looking. So here's Bella Vista. I see a little bit of clearing. It's cloudy, but we're already in the upper 70s with dew points in the mid 60s. But yeah, we are still capped. That's cloudy. That's Alma. Here's a look at see those winds picking up. Still pretty cloudy. But you know who's not cloudy? Harrison. Well, there's still a little bit of clouds, but there's a lot of sun and it's 80 degrees. So maybe the storms develop a little bit more to the east. It's a possibility. Decatur, that's pretty clear. So western Benton County is very clear. Siloam Springs, that's looking east. Let's spin that around and point that to the west. So let's look at some other models here. So I'm going to check this out as we look at some other computer model forecasts. Here's the graph 3 kilometer, which as we showed you doesn't really develop any storms. So it just basically brings that line through with temperature drop. It really would be surprising if there's no storms. Feels like the cap will break. It does to me too. It feels like the cap will break. We know how terrible these short-term models can be. Look at the graph barely even has any rain.
a little bit of rain right now.
Yeah,
Yeah, there
a little
is.
bit of rain.
Yeah, take that.
So it was a very weak shower over Silent Springs.
So let's go back to now. Here's what I want to do. I like what's called looking out the window. Looking out the window is definitely cameras, but cameras only see a certain distance away. Let's see if there's any type of upper level support. Is there anything that will cause these storms to lift or to rise more than what the models show? Let's show you this as we go on our water vapor, and we'll look here. Now, I definitely see some upper level support coming in right here. You can see these clouds moving in. Anytime you get high level clouds like this represents jet stream energy. So it's not very far away. You see it moving into western Oklahoma. If that in fact does move over us, that could spell thunderstorm potential. You also see a little bit of a wave. I'm going to go a little bit more higher resolution, and water vapor lets you know about these little disturbances. There's one that's coming through right there. Not quite strong enough to break the cap, but it did cause a little bit of that rising motion, which is what allowed those isolated showers and thunder showers to develop. Yeah, models are awful, Josh. I don't know what's going on, but there is something seriously wrong with them.
All that energy is behind the front, though. So if it stays behind the front,
that is the truth too. That's another thing to put into thought is that the front could outrace the upper level support.
I mean, why would it not?
Well, I mean, the upper level energy is moving a lot faster
think it's
than
gonna reach us.
20 miles. Yeah,
in that zonal flow.
It took 4.5, almost 5 hours to get across the Texas Canyon. I think the upper level support's lacking behind.
no, that's a possibility. Zonal's okay. I'm fine with zonal. I like westerly flow as long as there's pieces of energy. Right now, we're not really seeing a whole lot. So that the question is will storms develop? That is what we're trying to figure out. And I'll tell you this: I don't like when models are wishy-washy.
Kind of look at the jet stream.
Well, we're going to take a look at that.
That's
we're going to look at what I call a composite map. So this is like one of my favorites. So, check this out. Back it like this. So we go into here, and we bring up right here, full share. I'm going to present this, share the screen, and we're going to go to what I call a comp map. So this is the composite map. We'll bring this up full. And we'll take a look here. So this is the composite map. I'm going to bring this up full so you guys can see it really well. So let's see. There we go. So this is a look at this, what we call the composite map. The composite map essentially shows us where storms are going to be developing. And if we look at this, this is the energy. Boy, there really isn't a whole lot. Is it just going to be enough? That's the question. Maybe this comes through where no storms develop. That's not out of the question. I would be surprised. I do think that this is not as much energy as previously thought. You can see the rising motion is happening in southwest Missouri and northeast Oklahoma. And if we look at the jet stream, now there is some upper level flow, but there's not much curvature to the jet stream either. So the front, that's the front earlier. Now the front is actually pushing east and is already through the area. Another thing Peyton pointed out is the relative humidity. So the relative humidity is a lot less over northwest Arkansas. And while that can be good for creating steep lapse rates, it also kind of tells you that your energy may be lacking. So, Greg Reeves says, remember, Colby's in town. There really is something to this Colby thing. What looks so clear cut for storms, as we get closer.
Clear cut everywhere else until it gets to here.
In that MD, they were talking about stronger mid-level flow with the arrival.
See, you can see it. You can see it coming, but and models don't handle that perfectly either. So we go back to this comp map. And there you see that there's not a whole lot of forcing in it. If anything, there's a little subsidence behind this wave. Yeah. Subsidence is sinking air, and sinking air prevents
it's also drier.
Prevents thunderstorms from forming. So yeah.
That's why we had what, 60% chance?
Yeah, we went 60%, 40%. Now it is raining in spots. We're already seeing rain. If we look at maybe some of the cameras here,
take Siloam.
Yeah, we can do that. So let's go to Siloam here and we'll look. Yeah, so here's Siloam. Now you got it west. Wow, that is really sunny. So Siloam is super sunny. It's really interesting. You can see that's an anvil. I mean, there's clearly an anvil off in the distance. How do we know that? Well, you can see it in the middle of the screen. You can also see some of those towers trying to go up, but that shows me the energy and the support is not there. That is no way where this stuff has absolutely broken the cap. So we had a comment saying it is raining. Yeah, we can see that. We can see the raindrops on the camera.
Not anymore.
Yeah, you still do a little bit. There they are popping up behind the comment. So you'll see here at the bottom of that camera.
On the right side. In the trees.
Yep. So if we zoom in on Mega Doppler, you're going to see that little bit of light rain that's falling, which is what happened through Siloam Springs. But that's not thunderstorm activity. That's not thunderstorm activity. That's just a little bit of light rain. This is the storm activity, but then now that doesn't even have lightning with it anymore. It did.
It did. Yep.
But now it's capped. So I think it's a good time to go through what the cap is, and that's why we always say possibility or potential. We never say this is definitely going to happen. I got the lightning tie because I do think if storms do erupt and they're isolated, there's going to be a lot of energy where these storms could really pack a punch. But
isn't there some colder air aloft because of that system that was across the northern Rockies that's coming down?
Yeah, you would think.
So,
but it's actually not coming down at all.
Oh.
So EV's is asking, well, when does it hit northwest Arkansas? That's the $1 million question because there may not be any storms at all. So nothing gets hit. Nothing has any type of storm activity. We're just kind of breaking down the analysis. But I do want to show you this. This is the cap of the lid. And then if you want, we can actually bring up probably a sounding. This is a great explanation of the cap.
Want to bucket up?
Yeah, let's do that. Yeah. We did this last night, but in case you're watching now, the cap is a hot, dry layer of air that's above our warm, humid air that we can feel right now. So if we look at one of our WeatherBug network cameras from Mount Magazine, you can actually see that warm, humid air. Then you get above that warm, humid air where the clouds aren't as much, and you're looking in the haze, but you actually start clearing out. That clearing out occurs because you have cold, dry air aloft. So that's above the cap. So what we'll do here is we'll kind of put this into motion. What's happening now are these clouds are bubbling up. They're enough energy where they try to form into storms, but they can't do it because that lid or that cap is too warm. The hot, dry layer of air eventually may, as energy starts to swing in, starts to cool off those layers. And it doesn't take much, just a little small little drop in the cap, because warm air is going to rise as long as it's warmer than its surrounding air. Once it's not, it will start to become stable and sink even. But you'll notice here over time, this is what could happen when that cap does get broken and they fully utilize the upper level support. This is where storms could pop up. Now, I will say this. You can tell there is a little upper level support because these storms are trying to hold together. You can kind of see that. They're not dissipating completely. Yeah, we'll have to get a new graphics card on that. Now, here's another thing, too. Where does the cap come from? Well, here's a great example of how the cap forms. So we have this hot, dry air that comes off of the Rocky Mountains. As it's downsloping, meaning lowering in elevation, that causes the air to warm. And as you know, we got that southwesterly flow that is basically taking that southwesterly flow as bringing warmer air and strengthening our cap. So if we look, it's not a lot of flow, but yeah, I'm going to show you right here. So here is a look at the southwesterly flow right here on this graphic. And so what we want to do is we want to go back to this cap. So the warm layer of air essentially starts building in, and then that blows over the plains from that southwesterly flow. And the southwesterly flow is what prevents those thunderstorms from forming. So that's that warm layer of air. Well, how can we see that? We can see that by looking at what's called soundings, model soundings. But if that surface air either gets warm enough or the cap weakens enough, that's when your thunderstorms can develop. And because of the amount of instability, it won't take long, and you'll know when they start encountering that really unstable air. So now I want to go back to, is that weather 2, Zach?
Yep.
Yeah. Yep. Okay, so break us down with this as we bring this up full. This is essentially, hold on, we're going to bring this up. Here is the sounding. So this is the model sounding. So when that yellow line that you see on the screen is to the left of the red line, that means you're capped.
Yeah, use the cursor.
Yep.
Circle.
Yep. Where's the cursor at? Go back and draw it on the sounding.
Like this.
Yeah. So right there, you can see it.
Mm-hmm.
That right there is, think of this. You have a can of soda with a lid.
We have a severe thunderstorm watch though.
Okay, severe thunderstorm watch just got issued, so they're thinking that maybe this energy does start moving in. So you're going to hear the weather radio go on pretty soon, and here comes that severe thunderstorm
as soon
watch.
as it goes on.
No, let it go for a little bit. Let people hear it. And honestly, make sure that it's on. Okay, there's a severe thunderstorm watch. Oh, wait, turn it off so we can hear the tone.
Well, the white
Okay. Make sure it says NOAA on both of them. We definitely want it to say NOAA. Just got the watch. We have a watch. There you go.
watch and learn.
There's a watch. The question is what's going to happen? Well, let's look at the watch outline. So the watch outline will be the first to pop up. This is how this works. The watch outline will be the first thing to pop up. Then the Weather Service, what they're going to do is they're going to talk about the different counties that are involved. So if I go to these weather graphics, it may or may not be on here, and there it is. Okay, so we already got it.
It's got all the counties and stuff.
Yeah. Little Rock hasn't added their DMA yet,
Right.
their CWA. But so 3:37 to 11 o'clock, there's the severe thunderstorm watch. Now, the one in southwest Missouri is until 8 o'clock. Now, why would it be till 11? Well, that's a little bit tricky because the storms are going to be long gone and east of us by 11. However, this watch is a lot wider than what it shows on here. So if I go to the satellite radar, you'll notice that that watch goes all the way to east of our weather coverage area. But yet you're only seeing the weather service counties out of Tulsa. So that's why the watch looks like it's very skinny, but you'll see that increase in size as the weather service out of Little Rock adds their counties, which will be this row right here in our weather coverage area. I gotta take off that 8 p.m. There you go. My weather radio just went off.
These have not.
Is there a watch because it's growing? Well, let's read the latest discussion. So I'll read it with you as we check it out. We knew that might be coming. So they don't have a lot of stuff there. Here's what we're going to do. We're going to add this to the stream. So notice that there's no graphics. Everything kind of, yep, there it goes. It's updated. So the tornado probability or likelihood is low. The EF2 tornado is very low. Severe winds moderate. 65 knot winds low. Severe hail moderate, and 2-inch plus hail moderate.
60% probability. If you hover over that,
Yep.
it says 60%.
And I can also do this too. Go to the probabilities right here.
Oh, yeah.
So you got 60%, 60%. But yeah, if we go back to counties, yeah, see a lot of the graphics that haven't loaded yet, but there it tells you the probability. And they don't have the discussion yet. Oh, they do. They just don't have the graphic on the discussion. So here's what it says. Make sure that we've got this on the screen. Yeah, I know. It's a little, I'm going to take the camera off so you can see it full screen. So thunderstorm coverage and intensity is expected to increase along cold front. Was funny because models don't show anything. Robust buoyancy and strong vertical shear will support supercells of hail over 2 inches in diameter, damaging winds 45 to 65 miles an hour. Severe thunderstorm watch is approximately along 55 statute miles east-west of the line. So basically it tells you the size of the watch. This is what a watch means. Severe thunderstorm watch means conditions are favorable for severe thunderstorms in and close to the watch area. Persons in these areas, us, should be on the lookout for threatening weather conditions and listen for later statements and possible warnings. Severe thunderstorms can and occasionally do produce tornadoes with no warning, too.
Yeah.
As you
Learned that.
know. Yep. So there you go. That's the watch. And let me refresh this and see if it updates. There you go. Now you got the public outline. Notice how it's a little bit bigger than the box. That's because the Weather Service out of Little Rock is going to be out in their counties, and then you'll see that pop up on our weather graphic system. So let's see if I refresh it. Oh, yeah, there you go. Got Shreveport adding. So
Yep.
Shreveport added to the watch. It's going to be the same expiration time, obviously, because it's the same watch. 11 o'clock. Then you're going to see the eastern rows of counties start to get added. Let me go back to that so I can show you. This is my favorite time of the year.
It used to be mine until Miles went to garbage. Now they give you false hope.
Well, I mean, it's not
Well,
over yet.
sometimes, yeah,
It's not over yet.
It's that pre-storm doubt.
Do I remember the Rogers tornado in 2019? There was a couple of Rogers tornadoes. I know one in 2013. There was the one. I'm trying to remember 2019. Fall is my favorite time of year. Well, there's severe weather in the fall too.
October.
Just joining, is the cap holding? Ah, yeah, good idea, Zach. That's a great idea. Let me show you this. He's showing how these storms are not vertically developed yet. In fact, these are just the showers, right?
Yeah, this is in Western Washington County.
Western Washington County. We're starting to see something develop, but look at how over time it was popping up a little bit. There you go. So maybe this is trying to go. Look at on that last image. Looks like it was trying to get a little bit higher. Once it gets above that yellow line, we know that this sucker has broken the cap. Spring is mine except for tornadoes and pollen, which is basically the entire spring season.
Yeah.
The pollen is ridiculous right now.
Spring break until Labor Day.
All right, so here's what we got to do. We don't have any storms yet that we're tracking. The next time we come on, we'll be covering severe weather, and we'll get you through it. We'll let you know where these storms are. Right now, though, the cap is holding barely, briefly. However, we do expect that upper level energy potentially to come in and form some storms. But it's not out of the question if something just doesn't pop for us and it does develop. I don't know. Why is this? Why have the models been
We're asking the
garbage
same
lately?
question. Has something to do with the core
Yeah.
they run on.
I think it does have to do a lot with the core, and specifically the FV3 core. Here's the timing, by the way, of this, at least on what we have right now. So maybe went a little high at 4 o'clock. It's tough to do. Honestly, the timing, Jackie and everybody else that's asking about timing, it's probably the hardest thing in meteorology.
Yeah,
when
especially with isolated supercells.
you're talking about convection and thunderstorms. But there's a look at the essential timing with storms. Oh, yeah, of course, Drew. Why did I not remember that? That was October 21st, 2019. Yeah, that was wicked, man.
Yes. That's okay. I remember that now. I've never seen the video.
Yeah, October 20th. That just really, I don't know why I didn't even think of that. Yeah, October 21st, 2019. That shows you I'm starting to lose my memory.
No.
Yeah.
'Cause you'll remember a lot of other things.
Yeah, but like I like that was a big tornado, man. 31.4 miles, 1.5 miles wide.
See? You don't forget things.
Well, I just needed a jump. I
compartmentalize
needed to break the cap.
You're searching through the files.
That's what I needed to do. I needed to break my brain cap. Do you think it's going to start that early for? It could, because I'll tell you, with the amount of energy and the instability that we have, that would be a cool thing to show. These storms can go up in a hurry with the amount of, actually, there's something that's interesting with Cape. You can actually predict the speed of the updrafts by doing a very simple, easy equation. It's the square root of 2 times Cape, gives you meters per second in the updraft velocity.
Surface-based case.
Yes, surface-based Cape. So 2 times the surface-based Cape and the square root of that whole thing will give you that.
In meters per second.
So December 2015, April 2017, October 2019. Look at this guy. He knows dates. We had the big flood in 2015 in December. There's tornadoes in eastern Oklahoma. April was crazy. 2017, that was April 29th. We had flooding events. And October 2019 was pretty rough. Whoa, Robert says that tornado took down both trees in the yard. You know what was interesting, too, about that storm? The models did not show Northwest Arkansas getting the storms. It showed the river valley. And so we started talking about how Northwest Arkansas wasn't going to see severe weather just because that's what the models showed. And then I learned my lesson pretty quick on that, saying, you know what? Forget them. And then that's why when you guys asked, what about Bentonville? What about Rogers? What about Fort Smith? What about, Van Buren, Springdale? We can't tell you specific areas exactly what time the rain will be. I wish we could. If there was a model that was out there, then by golly, I would use it. And I'd be excited because it would make my job a whole heck of a lot easier. But right now, we don't have that capability. Rogers Heritage got slammed. Rogers High School. That tornado, in case you're wondering, for those that are new here and just came in and thinks, well, we don't get any severe weather. We don't get any tornadoes. Not necessarily. This is the tornado track, October 21st, 2019. So, first of all, there was already a tornado on the ground that would touch down in northeastern Adair County. Look at the time, midnight. We will not have the timing. That's one thing we know 100% for certain. It will not be this time of timing. Then you can see the storms moving east. And then there was a new tornado that touched down. And then this was like kind of like what we call mesocyclogenesis. And then the new tornado formed actually north. And at one time, there were two tornadoes on the ground at the same time. Now, watch this as this storm tracked northeast. It gives you an idea how wide it was. We had it on our WeatherBug network camera. Look at how it just barely missed XNA. But you guys know if you went to XNA and you traveled, you saw trees down all over the place on the south side of the airport. Then you see Pinnacle Country Club that gets impacted as we zoom in on that. So this went right through the heart of Rogers, Shadow Valley, and then on the east side of Rogers, Bonnie Grimes, Veterans Park. I'll zoom in so you can see some of the other schools that were impacted. There's East Side, Arkansas Arts Academy. There's Rogers Tech. And so that gives you an idea on some of the schools that were impacted. And then Veterans Park, and then it continued northeast all the way through Prairie Creek. And then it hit the Prairie Creek docks and then finally lifted as it made its way northward. Now, I know some of you said Beaver Shores had tornado damage, but I think it was honestly straight line winds. The trees were down all in the same direction. There may be some continuation of the path up here, but remember the Weather Service going to have a tough time surveying that.
Do you
all the way
remember
northeast.
that storm was properly warned?
It was tornado warned. However, it was not confirmed. We never had a confirmation. And one of the reasons was I was standing on the screen in front of the weather wall with the camera behind me. And I was standing where the power line flashes were happening. Plus, there were raindrops on the right-hand side of the camera dome. And we didn't have the technology to shake it and clear off those raindrops. So, couple things I learned. Number one, don't stand in front of a camera when there's a storm that's about to produce a tornado because I might be covering up the area that's most important. Keep looking at that too. You have to be vigilant looking at that radar and as well as the camera because a power flash can happen very quickly, very rapidly. And then the other thing that I learned too is that trust your instincts because I knew something was on the ground, but it just wasn't confirmed, and so we couldn't see it. If I would have been able to see those power flashes, I would have known it was confirmed, and that would have been very early on the south side of Siloam Springs because I know a lot of you didn't really know it was confirmed. So, all right, well, one last look at the radar. Someone was asking about it. Got the lightning tie on. We're still struggling for this storm to break the cap.
Yeah.
Do we still have that 4D analysis right here? Golly, it's so close. But you can see, look at how it doesn't develop and get any taller. Now, we know from looking at those soundings that these updrafts are going to be around 40, 45,000 feet tall. How do we know that? Well, go to back to that sounding and scroll the cursor up to the top to the equilibrium level. So there's the sounding. If we scroll the cursor up all the way, what does that say on the left-hand side of the sounding? What's the feet?
37,000.
37,000. So yeah, overshooting tops would be about 40,000. So we go back to our mega Doppler source, do it in 4D. You're going to see here how these cells, they're trying, but see how they lower? So that tells you right there that we're just slightly capped. Just slightly capped. Because if you move this along in time, it just hasn't, it's just not quite doing it. Now maybe that cell looks kind of interesting. Maybe that's one that's starting to move in that's a little bit taller than the rest. So maybe that's a sign that could be developing into a big thunderstorm. That's getting up there. That's what we call like a turkey tower right there. So that's a possibility. This is capped, and that's capped. But all that's keeping us is just that little layer of warm air, saving us from people replacing windshields and
Yeah.
windows and vehicle damage and stuff like that. Let's see here. So we got a lot of questions. Let's try to answer some of them, and then we'll shut this down here in about 5 minutes. Yeah, where are your lightning ties?
Don't have one.
Don't have one? Got to get
No.
it as a weather team. See, Peyton was saying I've already done the weather ties, so he can't do them. But
That's your stick.
yeah, but it's the weather team, man. We can do it. There's a frisbee call, of course. A tornado took down half the trees. Yeah. Well, you got to see the path. Oh, it's humid here. Yeah, it's very humid. In fact, the dew point now. Let's get the latest METAR data. I'm thinking it's going to be mid to upper 60s. Golly, man. Come on. That's so humid, and yet nothing's popping. And what was the reason, Peyton? Just no upper level support, right?
No, not a whole lot. You can see it there in western Oklahoma.
But is it gonna make it?
No.
You don't think it does?
Not in time. It will for central Arkansas,
Yeah.
southeast Arkansas, across the river. But for here,
Oh,
I think so.
yeah. And this is a great example too for people that look at models and all that stuff, and they're just like, look at how we're uncapped. Well, we're uncapped, but yet storms aren't popping. And why is that? Because they're lacking upper level support. I would say out of everything, be honest with you, in severe weather forecasting, the most important out of absolutely everything, in my opinion, is upper level support.
Yeah, you have to have it. You have to have the air moving out in the upper levels for this to be able to rise.
Yeah.
You have to, or else this won't be able to rise.
Think of it
No
this
one can.
way. If you're in a bathtub or if you're in a pool and you take your hands at the top of the water and push it away, what happens? You have water that upwells from the bottom to fill that void of water. That's the same way the atmosphere works. If you've got upper level winds that are spreading out the air, you have a void, and that air has to be filled in from the bottom, so that creates rising motion. That's why you see thunderstorms. And the way to look at upper level support, in my opinion, the best way is water vapor. Water vapor is key. And there's different types of water vapor. There's even better technology that's out there. We can only show one level on this weather graphic system, but it's so close. It's so close. It's approaching Oklahoma City now. You'll know when it gets here because those storms will erupt.
I think everything will be synced up east of us, like southeast of us. Everything will be synced up. By
Yep.
the time the front is there,
Hey, I'm all right with that. I
Yeah.
mean, we always said potential. Yes, maybe it didn't come to fruition. Some people might be upset. I'm fine with ducking
oh,
and
you'll have
dodging
weather one full.
large golf ball size hail. Yeah. So let me bring this up here. Here's a look at the water vapor. You can see that energy moving.
Yeah,
in.
so show that where the boundary is and where the upper level support is. How they're not
Yeah.
together.
So the boundary is located, and when we go back to the radar, that's the best way to see the boundary. Let's go ahead and switch the radar if we can now.
to INX.
Yeah. Even though we're looking into the boundary and looking east at the storms, there's really nothing to watch. So if we look at INX,
Yeah.
you're going to be able to see the boundary really well.
Mm.
But if I draw that frontal boundary on here, the cold front, it's going to be way east of that. So it's basically right here. That's where the frontal position is.
So that's our surface lift, yet the upper level support is off to the west.
Just
over Oklahoma
barely.
City.
I mean, maybe an hour.
But
or
it's
two.
it's racing to catch up. So not obviously, but the upper level support moves faster than the front because there's less friction in the air than closer to the ground. So they will beat up eventually, and that's where you will see a lot stronger lift. But as of right now, we don't have much upper level support. We have a good amount of lift. We're just not seeing the upper level support.
And it's interesting.
Don't
That's
beat
why
that.
the models were kind of wishy-washy. Anytime you don't have a unanimous resolution where they all show storms.
Yeah.
It just there's a lot of different models.
They were just unsure if they were ever going to meet up.
Yeah, it's a good point. If we go back to Mega Doppler, you can see the front right there on the screen. You can also see the glitching. I know
Yeah.
it's bad.
New graphics
I think
card.
we're losing
Should
that.
fix that.
We're losing that USB graphics card. Oh. But anyways, so that about wraps it up here. We'll answer just a few more questions. Again, we have severe weather update as we're giving you this. The tree went through. They're all talking about the tornado. I'd love to. I would just love to talk about severe weather and tornado, but we do have a 5 o'clock show. I'm leading it, and we got to figure out if we're going to see storms. So we got to look at more.
A new
But-
severe thunderstorm watch. Just now.
Okay. We'll have to
I don't
check
know
that
why
out.
that's different.
Maybe they issue
will
because
see.
Little Rock was having trouble adding their counties.
Maybe.
Friday, April 13th was the first tornado I experienced. Happened 1 week before the storm shelter opened. So that must have been Mountainburg.
Yes, those were the Little Rock counties.
Yeah.
They just got added.
So that's interesting. They must have had problems, so they had to add another. There they are right there. Finally they added. So there's the watch. But I want to go back to the latest risk. See how the front, obviously west of the front, no more severe weather risk. It's done. So yeah, Friday, April 13th, Friday the 13th. That was an isolated
Heard
supercell.
about that.
Seems like we don't get them anymore.
Storms back then were built different.
Thank you so much, Loretta. I appreciate that.
Right, she's right about that.
Turkey Tower, funny but serious business. So let's see if those updrafts are rising or if they're still capped. So we'll go back to Mega Doppler. So this is really actually very useful in terms of looking at storm activity. See, that looks like it's developing an anvil, but you just don't see any type of overshoot. So this is Mega Doppler in 4D essentially. So you see the depth, width, height. Now look at this. This actually has an overhang right here. See this, Zach?
Yeah.
That looks like it's trying to develop.
It wasn't there. Now it is.
But it is kind of sinking still.
Yeah.
Oh, see, yeah, we only have a few minutes of the data.
Pretty soon the
program
cameras
is
will be able to pick up that clouds.
Well, yeah, let's see. Let's do a little run through here. Let's look. So, yep, hit the middle button.
Shelf cloud.
And then-
These are some
Oh,
more
yeah,
super
no, you gotta,
cells.
now you got to go to this one.
Scenes.
Yeah, we'll make this a little more. So let's run through. You want to run through all of them?
Yeah.
Let's do that, and then we'll close it down. Josh, I'm not impressed. Shout out to Alexander Williams. Yeah. Oh, someone muted us. Yeah,
How'd that happen?
I don't know. Might have hit a mute mic button on the stream deck accidentally.
Oh,
So, how long ago was that at? 4:03? That was a little while ago.
minute.
402.
Yeah.
2 minutes ago. Well,
Let's remove that button.
yeah. So
Yeah.
you don't accidentally hit it.
Yeah, that's a good idea. Or put that on a page that you don't want, obviously. All right, we're back, obviously. Yeah, that's what happened. Hit that button right there. Mic mute. All right, well, that wraps it up. We'll watch this. We'll see if this line develops. And right now, it's so close. It's like a ticking time bomb. But if a little bit of extra lift as that energy moves in, you'll know it. Trust me, you'll know it when it comes in.
Yeah.
Because those storms will absolutely erupt with that amount of instability. Any last words?
We'll be watching it.
Yep. All right. Sorry about the audio going down. Apologize for that.
Yeah.
We'll remove that button. Yeah, we don't need that on there. All right. Take care. Have a good one, and we'll talk to you later. Thanks for watching. We'll see you later. Bye.